Welcome back, guys. Today we're going to take a look at topic 6.8, which is the laws of logarithms. And often you're going to hear me refer to them just as the log laws. Now, today we're going to look at each individual law. There's 3 laws that we're going to look at. And then in tomorrow's lesson, we're going to look at combining laws of logarithms. So combining our log laws into multiple or multi-step problems. All right, so let's hop right into it. First, we're going to take a look at the product law, and we're going to do each of these as an investigation. Normally in class, I'd be having you guys type these into your calculator, so feel free to follow along as we go through these. All right, so the first question here, we're asked to evaluate log base 2 of 16 plus log base 2 of 8. Now, if you remember, with a newer calculator, you can just type, you can actually do the log base by pushing your math button and then going to log base, it's letter A, and then typing it in. But with our older calculators, or with any calculator, we can enter it as log of 16 divided by log of 2. So log of 16 divided by log of 2 gives us 4. And log of 2, or log base 2 of 8, would be log of 8 divided by log of 2. And so that gives us 4 and 3. So we can write these as 4 plus 3, which is 7. Now, entering the next one into our calculator, we've got log base 3 of 27. So log of 27 divided by log of 3 gives us 3. And then using what we learned from our last class, log base 3 of 3, if our base and our argument are the same, that's equal to 1. So 3 plus 1 is 4. Now, taking a look at the next 2 questions here, we have log base 2 of 16 times 8. Well, let's start off with 16 times 8. 16 times 8 is 128. So we're going to go log of 128 divided by log of 2. And that gives us 7. And then 27 times 3 is 81, but we can double check that here. And log of 81 divided by log of 3 is 4. So we have 7, and actually I'll write that out. We had log of 128, log base 2 of 128 was 7, and here we had log base 3 of 81 was 4. Now the question right below that says, what do you notice? Well, if we take a look at our parts here, part A and C are the same, and parts B and D are the same. Now let's take a look at what's actually happened here. We have log base 2 of 16 plus log base 2 of 8. We took the 16 and the 8, so we took our arguments and we multiplied them together. So by adding our logarithms with the same base, we were able to multiply our arguments. And then over here we have log base 3 of 27 plus log base 3 of 3. Taking our logarithms, instead of adding our logarithms together, we can start off by multiplying our arguments. So that's our first law, and that's the product law. And so for the product law, what we're doing is we are multiplying our arguments when we have logarithms with the same base that are being added. All right, so let's take a look at the quotient law. This one here you might have already figured out, or might be able to figure out quickly. We're going to use our calculations from the last page, or the last example here. We have log base 2 of 16. Well, we know that from before is 4. Minus log base 2 of 8, which we know from before is 3. 4 minus 3 is 1. Here we have log base 3 of 27 from our last question. We know that that is 3. And log base 3 of 3, same base, same argument, is 1. And so 3 minus 1 is 2. All right, now checking out the next part here, we've got log base 2 of 16 over 8. Now you may have already figured out what these are going to be, but let's check them on our calculator. Log base 2 of 16 over 8. 16 over 8 is 2. So we have log base 2 of 16 over 8 is 2. Log base 2 of 2 is 1. And then the next one here we have log base 3 of 27 over 3, which is 9. And if we put log of 9 divided by log of 3 in our calculator, as you may have already predicted, we get 2. So again, similar to our last question, our B and D are the same and A and C are the same. And so again, we're taking a look at what's going on here. When we are subtracting logarithms with the same base, we can divide our arguments. Subtracting logarithms with the same base, dividing our logarithms. All right, so these are the first two laws that we have here. Our product law says that when we have the sum of two logarithms with the same base, we can multiply the arguments. Quotient law says that when we're subtracting logarithms with the same base, we can divide our arguments. So let's do some practice questions with these two laws. So the first question asks us to evaluate the following using the product law or the quotient law. So the first question, we are subtracting our logarithms. We have the same base, so we can divide our arguments. So log base 2 of 12 divided by 3 becomes log base 2 of 12 over 3 is 4. This we can put into our calculator and we get 2. So log of 4 divided by log of 2 is 2. Next one here, we are adding and subtracting. So we have the same base for all three. We can write 9 times 8 divided by 2. Well, 9 times 8 is 72, divided by 2 is 36. So we have log base 6 of 36, which gives us 2. All right, taking a look at our next question here. It says, asks us to use the laws of logarithms to write this expression as a single logarithm. So if we notice, all of our bases are x, so that means we can combine using our log laws. Brackets means that we need to deal with what's in the brackets first. So let's start off. We've got log base x of 10 plus log base x of 75 gives us log base x of 10 times 75, which is 750, minus, these have to be combined, log base x of 2 times 3. Now, because we have the same base, we can actually divide as well. So 10 times 75 is 750. 2 times 3 is 6. So we can write this as log base x of 750 divided by 6. Now simplifying, that gives me log base x of 750 over 6, which is 125. Now we would stop there, but we're asked to evaluate if x equals 5. So we can rewrite this as log base 5 of 125. Putting that into our calculator, we get 3. All right, moving right along. The next question says that the expression log base 2 of x plus log base 2 of 2x minus log base 2 of x squared can be expressed as one of these values. So let's see which one it is. We're adding, meaning we're going to multiply our two arguments, and we're dividing, meaning we're going to we're subtracting, meaning we're going to divide x squared from the x and the 2x. So writing this out, we're going to have log base 2 of x times 2x, all divided by x squared. Simplifying, that gives us log base 2 of 2x squared divided by x squared. Simplifying, we're left with log base 2 of 2, and we know from our previous identities that that is equal to 1. All right, now number 4 is a question you might want to put a star beside. These are questions that are quite common. We're given a logarithmic expression, and then we're also given an equation, and we have to use one to find the value of the other. So we're asked to determine the value of 3 log base 2 p minus 3 log base 2 of q if p over q is 8. So before we can actually use that 8, we need to somehow get an expression that's p over q. And we're going to use our log laws to do that. So the first thing we're going to do is factor out a 3. Now we'll be seeing another identity shortly where you'll actually have another way to simplify this. But we factor out the 3, and that leaves us with log base 2 of p minus log base 2 of q. Now using our log laws, we have the same base, so we can divide our arguments. So we have log base 2 of p over q. Now, we have the expression p over q, so we can replace the p over q with an 8. So rewriting that expression, we're going to have 3 log base 2 of p over q, which is 8. And log 8 divided by log 2 is 3. So we're left with 3 times 3, which is 9. Now, coming back to this later on, I will show you how we can use a different identity to simplify this in a slightly different way. All right, moving on to our final law here, and that's the power law. So first of all, we're going to look at some expressions that can be simplified. So the question says, by writing 2 log x as log x plus log x, show that 2 log x equals log x squared. Well, 2 log x just means that we have 2 logs that are being added together, so log x plus log x. Well, using that, log x plus log x, using our product law, we know that we can rewrite that as log x times x, which becomes log x squared. So when we have our number in the front, we can actually bring it up to become our exponent. So the next question says to prove that log base 2 of a equals log base 2 of a cubed. Well, anytime we're asked to do a proof, you want to make sure to use left side, right side. So LSRS. And then you put your left side on one side and your right side on the other, and you simplify both sides until they look the same. Sometimes you only have to simplify one side, sometimes you have to simplify both sides. So we've got log base 2 of a cubed. Now, looking at these here, I'm going to write the left-hand side as 3 separate logarithms. So I can write that as log base 2 of a plus log base 2 of a plus log base 2 of a. Using my properties, that means that I can write this as log base 2 of a times a times a, which is a cubed. And so these are equal, so it's the same. You could have just as easily taken the log base 2 of a cubed and written it as log base 2 of a times a times a, and from there got to log base 2a plus log base 2a, and so on. So it doesn't matter which side you simplify as long as you get to the final answer. All right. Now our next step here asks us to write an expression equivalent to a log base b of c. Well, using what we've learned already, the a value can come forward. So a log base b of c can be written as log base b of c to the exponent a. And that's essentially our power law. So the log base a of m to the exponent n is the same as n times log base a of m. So essentially our n will come forward. So let's take a look at a few more examples here. All right, so the first question here, it says to write the following in the form n log x. So our first expression is log of x to the 10. Well, that 10 is going to come forward, and we're going to have 10 log x. And if you remember, that means there's actually, or when we have just log x, that means our base is also 10. It's just invisible. We don't write it. For the next expression, first we're going to have to put our argument in exponential form. So we've got log of root x is the same as log of x to the 1/2. Our 1/2 comes forward, and we're left with 1/2 times log of x. Now we can also write these in another form, and that's to go from logarithmic form and bringing that coefficient forward to become an exponent. So we can have log x to the 5th. We can have log x to the negative 1/3. Now using this, we're going to take a look back at our last question that we did on the first page. And this is where we had the 3 log base 2 of p minus 3 log base 2 of q. Now what I'm about to show you here actually relates to what we're going to use tomorrow, but I just want to show you how we can simplify this in a different way. Now, using what we know about the power law, we can actually bring this 3 forward, and so we can also write this as log base 2 of p cubed minus log base 2 of q cubed. So log base 2 of q cubed. And then using our quotient law, we can still divide our arguments. So we're going to have log base 2 of p cubed over q cubed, which is the same as saying log base 2 of p over q cubed. Now continuing on here, that gives us log base 2 of p over q, which was 8 cubed, and that's log base 2 of 8 cubed, which is 512, And if we take that 512 and go log 512 divided by log 2, we will get 9. So log of 512 divided by log of 2 will give us 9. So again, we can use other properties to simplify. All right. Moving on to example number 7. We're asked to write the following in the form n log base b of x and then evaluate. So we're going to bring this 2 forward and we're left with log, or 2 in front, 2 log base 2 of 8. And that's going to give us 2 log base 2 of 8 is 3. So 2 times 3 is 6. Next one, we've got 6 log base 49 of 7 cubed. So the 3 is going to come forward and multiply by the 6. That's going to give us 18. Log base 49 of 7. Log base 49 of 7 is 1/2. So 8 times 1, or 18 times 1/2 is 9. Next example, we've got 6 log base 49 of the cube root of 7. So first we're going to write the argument using exponent. So 6 times log base 49 of 7 cubed. The cubed will come forward, multiply by, or sorry, not cubed, 1/3. The 1/3 will come forward, multiply by the 6. 6 times 1/3 is 2. And that gives us 2 times log base 49 of 7. 2 times 1/2 is 1. And lastly here, we'll bring the n forward, and we've got n times log base 6 of 6. Well, we know that this is equal to 1. So we end up with n times 1, which is just n. All right, last question here. It asks us to use the power law of logarithms to prove that log base 4 of 16 to the x is the same as 2x. So again, using proofs, we're going to set up our left side, right side. And we've got on the left side log base 4 of 16 to the x. And we want to show that that can equal or is equivalent to 2x. So first thing we're going to do is bring our x forward. So we're going to have x times log base 4 of 16. And we can rewrite our 16 as 4 squared. So we're going to have log x times log base 4 of 4 squared. That 2 is going to come forward. Now we have 2x times log base 4 of 4. And we know again from our identities before that log base 4 of 4 is the same as 1. And so 2x times 1 is 2x. And so these are equal. So if we can write our argument in the same base as our base, we can actually simplify even quicker. So let's take a look at a couple examples here. We had for part A, log base 2 of 8 squared. Well, let's look at solving this a slightly different way. We can bring the 2 forward. So that's going to give us 2 times log base 2 of 8. But we can write 8 as base 2. So that gives us 2 times log base 2 of 2 cubed. When that 3 comes forward, we're left with 6 times log base 2 of 2. And since we know that log base 2 of 2 is 1, we're left with 6 times 1, which is 6. Some of them get a little bit more complicated. For example, numbers or letter B here. We can do this one as well. That's having to write 49 as, or 7 as base 49. But we can do that. So for this particular question, I would have 6 times log base 49 of 7 cubed. The cubed is still going to come forward, and so we're going to have 18 times log base 49 of 7 cubed, or sorry, not 7 cubed, sorry, log base 49, and then we have to rewrite this as 40, or base 49. So 49 to the 1/2, in other words, the square root of 49 is 7. That half comes forward, and half times 18 is 9. So 9 log base 49 of 49, that becomes 1, and we're left with 9. So when we start getting into square roots or fractional exponents, sometimes it's a little bit more complicated, and sometimes it's just as easy to do it on your calculator. If we go right back to that last example we did on the first page, Again, I'll show you one quicker way that we can solve when we get to the point of log base 2 of 8 cubed. Well, we can write that as log base 2 of 8 cubed. The 3 will come forward, and we've got log base 2 of 8. Now, 8 can be written as base 2. So log base 2 of 2 cubed. The 3 is going to come forward. 3 times 3 is 9. And we've got log base 2 of 2, which is equal to 1, which also gives us 9. So one example, this example number 4, can be done in 3 different ways once we get to a certain point. But ultimately, we still have to start by combining our logarithms so that we can get to that P over Q. All right, guys, so that gives you quite a few examples for the laws of logarithms. Make sure you're familiar with these and you've had a little bit of practice because tomorrow we're going to use these exact same laws and we're going to combine them together into multiple step problems. All right, thanks. Have a great day, guys, and we'll see you soon.